So we're going to try this again. This is the second take. I recorded 10 minutes of video and I didn't realize that I was having microphone problems, so ended up sounding terrible. So we're going to try this one more time. I am back. We're going to jump right into graphics, and here we go. So the first thing we want to do is load up right here Sega Genesis Tile Designer. Now this is what we use. Sega Genesis Tile Designer, and this is what we're going to use to make our Sega Genesis graphics. Now, if you can recall that this is this is what we installed in the beginning, and a tile is an 8x8 box of pixels that represents screen data. So we want to get it down to 8x8. Right now it's at 16x16 if you see down in the corner. So to get it at 8x8, we're going to want to change the tile height. Now right in this picture there are 4 tiles, so if we change the tile height to 1 and tile width to 1, there were actually 4 tiles in the 16x16 because, you know, yeah. So we're going to want to turn the grid on to start we're going to make our first graphic, which is going to be a smiley face. Now, also, since we're going to only be making 1 tile in this video, we won't need all these other extra tiles. So we can delete those. Right. And so you could just select the color down here. The L and the R represent your left and right click. And just to point out, this first color, the first color represents the background. So once we load this graphic into the Sega Genesis, that is going to be our background color. Just something to note. So you just click into this grid, and that will be your graphic. Now I'm going to be making a smiley face, a green smiley face. We could fill him using the fill tool, green, and give him some eyes. That's pretty good. We don't need a mouth, does he? Yeah, let's give him a mouth. And we can turn off the grid, and there we go. That's how it's going to look on screen. So now that we have our graphic done, we're going to have a way to put it into our Bex program. So let's click this export tile data right here, and we can export it by using this. I usually do binary because it's much easier to deal with and generates less code. However, just so you can see how the graphics work, we're going to generate the data in BASIC. So this is the actual code that represents the graphic we've just made in BASIC in hexadecimal values, which with each hexadecimal value representing a thing. You see F would be black, 0 would be white, and 5 would be green. So if you can plot all those out, you're going to get this face. So to put that into our program, we can copy this, close it out, and paste it right in. Now if we compile and then load our emulator, please bear with me, I don't have the automatic thing. It doesn't work here because I got a new computer. We can run it and nothing's happening. So nothing's happening because we're going to have a way to load it into the Sega Genesis memory. So we don't really have a way of displaying it on screen. So first of all, we're going to have to give this guy a name. We're going to call him GUI guy. Now that is a label, so we can go to this and call this data whenever we need to. So to put this into memory, we're going to have to load it. So the first command we're going to use is load. So load tiles, GUI. So because that's the name of the label. So first we're going to put the label, which is GUI. Then we're going to see how many tiles we want to load. Let's load 1 because this is it right here. And we're going to load at location 300. Now why? And because when you load it, you have to put it into memory, and memory location 300 is a good place to start. Why not use anything less? Because digits spanning between 0 to 255 are actually filled with the letters and numbers and characters like A, B, C, D, E, F, G, all those numbers, symbols like that. That's all occupied in the RAM as well as graphics. So we don't want to override those, or else we're going to have some problems later. So now that we've loaded our tile, we can run it, we can compile it, then reload the ROM. For you viewers, all this would come up automatically, and still nothing happens. Now, even though we have it loaded, we're going to have to display it on the screen. So let's use a command called draw tile. Draw tile basically takes your tile, this one, 300, tile number 300, and draws it on the screen at tile location 4 by 4. Now 4 by 4 represents 4 8 by 8 tile spaces. So 4 times 8 going across, so that would be 32 pixels across and 32 pixels down. So it's going to start at real location 32, 32. But since this is a tile, we just put 4 by 4. That is fine. Now, even if we run it, it's still going to be black, and the reason why is because we haven't loaded the colors. Now, this is a color image, right? So this is a color image, and to import the colors, we're going to have to do the same thing as we did with the actual tile data. We're going to have to we load colors by double-clicking on one of the colors down here in the palette. So let's double-click, and these are all the colors that are stored into the memory. We can click Export Palette, same thing as last time, Generate Data, and these are all the colors representing our character. Now, even though we're not using all of them, we can load them all into memory in case we need them later. So we could just use another label, COL, for color, paste it in, and let's paste it in. But we still haven't actually loaded the colors. Just like how we have to load the tiles, we have to load the colors too. So we have to use a command called palettes, and we have to define the label where all this data is located. So COL, that's a label, and we have to. Sorry, I haven't used this language in a while, so I just had to review some syntax. So you're just going to have to, so palettes, right? You first start with the label, then we put 0 because we're using palette number 0, and 0 because this is color entry number 0. So these are the first colors we're inserting into the system. So after we do that, we have to say how many colors we want to load. So there are 64 different values here, so we can just type in 64. And that should cut it. We've loaded the colors, we've loaded the graphics, and we've drawn it onto the screen. Now, to make sure we don't have any problems, we could just stop the execution here by doing a do loop. Now basically, this is the same thing as doing something like this. So when it comes here, it says, alright, I'm going to come to loop, I'm going to come back here and go back and forth between these two commands. So to put that all into one line, you just put a colon. So this basically pauses the program, or loops it, so it doesn't really do anything else. So we can compile it. It's compiled. Go into Sega Fusion and load our thing, and there is our guy, our first Sega Genesis graphic. So the next step would, well, the thing is about this guy is that he's stored in as a background tile. So a background tile, it's a tile, but you can't really move it around. You know, it's just part of the background. So we're gonna have to turn this guy into a sprite. So we don't have to delete him. We'll just make another one. So we have all the data loaded up. Excuse my cough. I'm a little under the weather right now. So then the next step we could do is make a sprite. So to make a sprite, we just type in s equals add sprite. So in the program, we're going to call it sprite s, and we have to say how many tiles large we want him to be. So since we only used one tile to make this guy, we're going to make him 1 by 1. That means 8 pixels by 8 pixels wide by 8 pixels tall. So after we made our name for him, we've defined him in the program. Now we can attribute his graphics and colors to him. So to do that, we use a command called prop sprite. So prop sprite, you basically take the sprite number, which is S, or a sprite variable, and you take the tile number. So the tile number is 300, because that's what we defined here. And we have to use the color palette. So the color palette we have stored down here, which is COL. So now that we have our sprite properly defined, our sprite exists now in the memory, and now we can put it onto the screen. Now the thing is with sprites is that you want to reload them every time the game loops through. So we're going to do that inside this loop. So we're going to do move sprite, which displays it and allows you to move the sprite around. So move sprite. There are other ways to move the sprite, but this is how you display it. Move sprite S, right? And this is going to be your X value, and this is going to be your Y value. Now we haven't defined these yet, so we're just going to go here and type X equals, let's say, location 80. Look, X 80 and Y 80. Oops, Y equals 80. Now, this is all fine and dandy. However, the sprite graphing, like the way the sprite is displayed on the screen, it's kind of offset by 128. So if 80 here is not really going to be 80, it's going to be some big number, some random number that is going to get you confused. So just to prevent any confusion, just type plus 128 on the X and plus 128 on the Y. You should do this every single time you display a sprite, because if you don't, things are going to get kind of confusing. At least they were for me. I just do that so everything starts at 0 and ends where it should at the Sega Genesis resolution, the screen resolution, the proper screen resolution. That I don't quite remember right now. So we can compile. Oops, that was compiled. Sorry about that. And reload. So when we reload, there should be a sprite somewhere in this area. It's going to look the same as the tile. There we go, right there. That is our sprite. Now, to be able to move them around, it's pretty simple. We just use the joypad command. So if joypad dot O, which is up, if you installed Bex and go into the help file, the help HTML that I refer to for stuff, if you go here, then you're going to find the joypad reference. So this is joypad.0 is the equivalent of pressing up on your Sega Genesis controller. If it equals up, then SY, or Y, sorry, I usually do SY for sprite Y, but we just have X and Y here, so that's fine. And Y equals Y minus 1. Now to make sure it doesn't go too fast, we're going to slow it down. Sleep 1. That just slows down the processor just a little bit, so it's playable. Because if you don't do that, it's going to go too fast, and it's just going to be a mess. Trust me. So we can run that now. Reload, and when we press up, the sprite goes up. So that's pretty cool. So you can go up now. Now let's make them go different directions. So let's make it go down. Down is 0.1. So we could do plus, right? And left and right. So I'm just going to make some comments here just so you can see. So up. Oops. Down. Now we're going to do left and right. So dot 2. X. Oops, sorry about that. Now if you're confused what I'm doing here, basically, because I didn't explain that, it just means that you take the pixel value, like because these are just like the pixel locations, the raw locations on screen, It just allows you to go back one and forward one, or up one or down one. It just translates your sprite across the screen, just like in the last tutorial. Left, right. Alright. Oh, my bad. The problem I was having is it looks like I found a little glitch with this program. Or not with this code, but with the Vex itself, is that you can't do comments like this on the same line as an if statement, or else it's going to generate a little error. Or you could do it like this, oops, and if, then you could do a comment anywhere you like. So that's up, right? But for demonstration's sake, we've done all the stuff we need. You don't need to do this. This is just another way of doing it. If you wanted to do animation or something with your tiles, then this is how you would do it, because you'd be able to like say, okay, I want to switch the tile number 300 to another sprite, which would animate it. So here we go. Run that again, and the sprite is there. And if we use if we use our controller, it moves around how we want it to, and we can walk all over the tile and go up and down all around. So that was a tutorial on how to do graphics. In the next tutorial, I'm going to show you how to do maps, if I ever get to it. But I'll see you next time. Have a good one.